Alright, so for question 2.4, we are basically asked to do 3 union sets in order to get one entire set, right? So since there are 4 sets, as long as we do 3 union sets, you'll be able to get 1 set. But they're asking how is it possible to do these union sets in order to get the tree that is as tall as possible and a tree that's as short as possible. So in order to get a tree that is as tall as possible, firstly we think about how to union these things, right? So if I straight away union 3 and 5, right, 5 is just going to go under 3, right, and the rank is still going to be 2, so it's not really helping in increasing the height of the tree, right? What we realize here is that what we can do is to union 5 and 7 first. And since the rank are the same, right, we just randomly choose one of them to be the one to be connected to. So for instance like this, and maybe this becomes a rank of 2, right? So the first thing we do is union set 5, 7, right? Following this, now this is a rank of 2, and this is also a rank of 2. So if we union set 3, 7, right, what we're going to get is, since both are the same rank, one is going to point to another. So let's say 3 points to 7, right? So 7 becomes a rank of 3, right? And finally for 8, we can just union set 7 and 8, and since it has a lower rank, it is just going to point to a 7, right? So eventually what we're going to get is 7, which is have 3, 1, 0, 2. 7 also has 5, 4, also 6 and 8, right? So we're going to get this after we do union set 7 and 8, right? So in this case, we're going to get a tree of height of a tree, right? So this is going to be the maximum height that we can get, right? So a few key things to note here is how firstly we have to union these 2 sets before we union this set, this bigger set, with this, right? If we just union this with this, right, this is just going to be still a rank of 2, and then we union this with this again, it's still going to be a rank of 2, and the height of the tree is not going to increase, right? So what we have to do is to increase this rank to 2 first, so that when we union these 2, right, one of them is going to increase in height. The other thing is that when we union sets, we want to union the parent of the set, which in this case are 3, 5, 7, and 8. So realize that all the numbers here are 3, 5, 7, and 8. The main reason being that, let's say if I instead do, let's say, union set 0 and 5, recall that in the union of set, we actually have to do the find set operation, right? We have to find the parent first. And during the find set operation, it actually already does path compression. So if we do 0 and 5, even before we merge this, union the sets, 0 is already going to point to its tree. So we actually reduce the height of the tree through the path compression in that way. So when we union the sets, we want to union the parent of the set, so that when we do find set, we do not actually do any kind of path compression, right? Correspondingly, if we want the tree to be as short as possible, right? If we want the tree to be as short as possible, then we will want as much path compression as possible. So what we can do is we can, for instance, union set of 0 and 4, right? So when we do union set of 0 and 4, so it's going to do find set of 0 first. So what's going to happen is it's going to be something like this, right? And then we'll have something like 4 and 5, right? And because the rank of 5 is 1, right, it's going to be something like this. And then subsequently what we're going to do is we're going to union, right? We still have 7, 6, and 8 here. So what we're going to do is union, let's say 6 and 4. Right? Okay, so the rank of this is still 2. Right, we're going to union 4 and 6, right? So by unioning these 2, union set 4 and 6. Firstly, when 4 tries to find the parent, there's going to be path compression. So this is going to be 0, 1, 2, 4, 5, right? And since this is 6, 7, right? Since 7 has a rank of 1, it's going to point like this, right? And we have 8 here. And finally, what we are going to do is union set 6 and 8, right? Once again, path compression is going to happen here. So even before we union, we have 0, 1, 2, 4, 5, 6, 7, right? And finally, 8 is going to be union here, right? So notice here that well, firstly, when we union sets, if we want the tree to be as short as possible, we want to union sets that are on the leaf, and especially at the sites whereby it's further away from the root, so that you can actually do some path compression. In this case, it's wise to actually put 8 as the last thing to union, so that you can do the last path compression for 6 here, right? So anyway, this is the answer for question 2, this part, and this is the answer for question 1.